Now we've solved absolute value equations. Let's look at absolute value inequalities. And so in our first example, we're going to look at what happens when I have absolute value less than a number. So you can see here from our example, absolute value is less than 3. Notice where the distances from 0 are less than 3. Notice they're in the middle. They're in the middle. That means when we have less than, we have an intersection, an and. It's always going to be in the middle. So one way that I encourage you to remember this is that when we're dealing with less than, it's less than. It's always an intersection. It's always an and. So let's look at question number 14. The absolute value of 2x plus 3 is less than 5. Because it's less than, it's going to be an and. That means 2x plus 3 has to be between -5 and +5 because the distance from 0 is less in the middle. Solve it as a compound inequality. So we're going to do -3 on all three sides. -5, -3, that's -8. Less than 2x, less than 5 minus 3 is 2. Then I'm going to divide by 2. That gives me -4 is less than x is less than 1. So set builder notation, x such that -4 less than x less than 1. Interval notation, there's no equal to, so parentheses -4, 1. Okay, just like with absolute value equations, I don't deal with the absolute value until it's isolated. So I'm going to subtract 2 before I do anything. Notice I am writing this inequality over again with the absolute value. So I started out with absolute value of 2x plus 5, plus 2 is less than or equal to 2. Subtract 2 to move it to the other side. It's still absolute value of 2x plus 5 is less than or equal to 11 minus 2 is 9. I do not take the absolute value off until I'm ready to do the and or compound inequality. So 2x plus 5 is in the middle, and my distances are less than between -9 and +9. It's equal to because my original inequality is equal to. So I'm going to subtract 5 from all three sides. So -9, -5 is -14, less than or equal to 2x, less than or equal to 9 minus 5 is 4. Divide by 2. -7 less than or equal to x less than or equal to 2. So again, set notation is -7 less than or equal to x is less than or equal to 2. Or interval notation, brackets, -7, 2 with a bracket. All right, so we've done less than. Now let's talk about greater than. Where are the values or the distances greater than 3? Well, if you think about this number line, the distances from 0 that are bigger than 3 are going to be these distances outside of -3 and 3. So notice how they point in opposite directions. When you're solving absolute value inequalities that are greater than, you will always end up with this whole idea of going in opposite directions because it's outside of the middle. And so how we solve this is we actually just do that whatever the value is inside is going to be less than the negative number and greater than the positive. And again, absolute value, you must have it isolated first. Now, just like I had a way to remember, with less than, we have a way here. If it's greater, then it is great or being a union or being the outside. So how do I solve this? Well, in this problem, the absolute 5 times the absolute value of 2x minus 1 minus 1, I'm sorry, I read that wrong. 5 absolute value of 2x minus 3 minus 1 is greater than 9. So I have to isolate first. So plus 1 gives me 5 absolute value of 2x minus 3 greater than 10. And again, I said it in the equations, absolute value equations video. I'm going to say it again here. Do not distribute over absolute values. Absolute value is an operation, not a grouping symbol. We do not distribute. To get rid of the 5, I'm going to divide by it. So it's absolute value of 2x minus 3 is greater than 2. Notice I did not remove the absolute values because I have not done anything with that. Now that I've got it solved for, I see that it's greater. So I'm going to say that 2x minus 3 is less than negative 2. That's going off to the left. Or 2x minus 3 is greater than 2. Again, stressing that or. Solve each one of these. So plus 3. 2x is less than 1. So x is less than 1/2. Or plus 3 plus 3. 2x is greater than 5. So when we divide by 2, x is greater than 5/2. Now if you think about that on a number line, here's 0, here's 1/2, 5/2. It's less than 1/2 and greater than 5/2. So we've got that going in opposite directions. My set builder notation is x such that x is less than 1/2 or x is greater than 5/2. Notice again, all I've done is put that or in between them. With interval notation, we're going to write this with a parentheses negative infinity, and I'm going to stop at that 1/2. It's a parentheses because it's not equal to. Unioned with, there's that u again, parentheses 5/2 to infinity. Now notice my negative infinity is on the left. My positive infinity is on the right because I have arrows pointing in both directions. All right, let's look at this one. So again, I need to isolate the absolute value. So don't distribute. This is 1/5 of the absolute value of 3x plus 3 is greater than 3. So I'm going to multiply by 5 to cancel out that 1/5. So I end up with the absolute value of 3x plus 3, I haven't changed that, is greater than or equal to 15. Now I can say, okay, it's greater, so that means 3x plus 15 is less than, 3x plus 3 is less than negative 15, or 3x plus 3 is greater than positive 15, and greater than or equal to. Let's not forget that these are equal to. And then I'm going to solve those. So I'm going to subtract 3. So 3x is less than or equal to negative 18. When I divide by 3 here, I get x is less than or equal to negative 6. Or minus 3 here, I get 3x is greater than or equal to 12. Divide by 3. X is greater than or equal to 4. So again, looking at my number line, negative 6 is over here, 4 is over here, equal to gives me closed circles, less than negative 6, greater than 4. I can see that I've got that whole going in opposite directions thing. Set builder notation, x such that x is less than or equal to negative 6, or x is greater than or equal to 4. My interval notation is longer because I'm going to have negative infinity. Stops at negative 6. It's included, so that's a bracket. Unioned with, pick it up at 4, equal to means bracket, and goes to infinity because it points off to the right. Now, a couple of special cases to talk about real quick. The absolute value of 2x plus 1 is greater than or equal to 0. Well, let's remember what the definition of absolute value is. It is the distance from 0. And a distance is always going to be positive, which means a distance is always going to be greater than 0. So in this case, this is all real numbers because no matter what I put in for x, it's going to end up greater than 0 because I'm taking the absolute value of it. Okay, so you can say negative infinity to positive infinity. Graphically, what I would do is I would just go a line over the whole number line. Okay, the other special case is this less than negative 4. So the absolute value of 6 minus 5x is less than negative 4. Well, the distance, we just got through saying, it's a distance from 0, which is always positive. If a distance from 0 is always positive, then I can't have the distance from 0 being less than negative 4. So this would be an example of no solution. You can't have absolute value less than a negative. And again, no solution can be written like that, and it can be written as the empty set. Number line wise, we would just leave a blank number line. So let's do some application problems. The pH of the water in a public swimming pool should be maintained at a safe swimming value of 7.4. Slight variations in the tested value of the pH levels are acceptable, but should differ from the ideal pH balance by no more than 0.2 or 2/10. If X represents the exact pH value tested, write an absolute value inequality that represents a safe interval for X. And so how would I solve this? Well, the absolute value, remember, is the distance away from 0. Well, we want the distance from X, which is the normal is 7.4. So we want the difference between 7.4 and X. We need that to be less than or equal to 0.2 because we need the difference to be less than 0.2. And again, this is the and that gives me my interval I'm looking for. So X minus 7.4 has to be between negative 0.2 and positive 0.2. And so to get my answer, I'm going to add 7.4. And so I get 7.2 is less than or equal to X is less than or equal to 7.6. So my interval that the test needs to fall in is 7 and 2/10 and 7 and 6/10. One cell phone service charges a flat rate of $35 a month plus 1 cent per text. Another company offers a flat monthly fee of $50 with unlimited texting. How many texts would you need to send for the first company to charge you more per month than the second? So let's write these two equations. So one cell phone charges a flat rate of $35 a month plus 1 cent per text. So they charge you $35 a month plus 1 cent per text. The other company is just $50. And what it's saying is how many texts would you need to send for the first company to charge you more than the second? How many texts do you need to send for 35 plus 1 cent times X to be more than the other? So this is the problem we're going to solve. 35 plus 0.01X is greater than 50. So we're going to subtract 35. That gives me 0.01X is greater than 15. I'm going to divide by 0.01. So X is greater than 1,500. So you would need to send more than 1,500 text out for the first company to be more expensive than the second.